If someone asked you right now, Wi-Fi, Bluetooth, or ZigBee, which one would you choose for a wireless sensor network with 20 battery-powered nodes? Most people say Wi-Fi first. Some say Bluetooth because of the low power reputation. Almost nobody says ZigBee. This is a ZigBee radio module, the hardware that makes everything in this series possible. It runs on the IEEE 802.15.4 standard, built from the ground up for exactly this kind of problem. By the end of this video, you will know exactly why 3 wireless standards exist, what each one was designed for, and how to make the right call on your next project, without guessing. Here is the problem. All 3 of these protocols, Wi-Fi, Bluetooth, and ZigBee, work. They all transmit data wirelessly, but each one was built to solve a completely different problem. Wi-Fi was designed for one thing, giving you fast internet access. It assumes your devices are plugged in. It is optimized for high throughput, and it treats every device as an equal node on the network. That works perfectly for 12 people streaming video. It starts breaking down when you have 50 sensors that need to check in every few seconds on a single battery for 2 years. Bluetooth was designed to replace cables between 2 devices, your phone to your earbuds, your laptop to your keyboard. It is excellent at that. But the moment you try to build a real network with Bluetooth, more than a handful of nodes, traffic routing, fault tolerance, you are fighting the protocol, not using it. ZigBee was designed from the beginning for large networks of small devices that need to run on batteries for months or years, in environments where Wi-Fi would struggle to survive. That is a very specific design goal, and it produces a very specific set of capabilities that the other 2 simply do not have. Frequency. All 3 operate at 2.4 GHz. That is not a differentiator. What matters is what each protocol does with that spectrum. Network topology. Wi-Fi is star topology. Everything goes through one central router. Bluetooth is point-to-point, or small piconet clusters. ZigBee is full mesh. Every node can route traffic for every other node. This single difference explains almost everything about when to use which one. Power consumption. Wi-Fi, high, designed for mains power. Bluetooth, low energy, moderate to low, good for burst transmissions. ZigBee, extremely low. A node can sleep for 99% of the time and wake only to transmit, which is exactly how you run a sensor on a coin cell battery for 2 years. Number of nodes per network. Wi-Fi. Practical limit is roughly 30 to 50 on one access point before performance degrades. Bluetooth. 7 active devices in a piconet, though BLE mesh extends this somewhat. ZigBee. The IEEE 802.15.4 specification supports over 65,000 addresses in a single network. In practice, however, stable deployments typically run 100 to 200 nodes, constrained by coordinator memory, router capacity, and traffic volume. That is still an order of magnitude beyond what Wi-Fi handles comfortably, and for industrial sensor networks, it is more than sufficient. This is the hardware I use for most of my ZigBee work. The XB-S2C module from Digi International. It implements the ZigBee protocol on top of IEEE 802.15.4, which is the physical and MAC layer standard that ZigBee is built on. If you see 802.15.4 in a datasheet, you are looking at the same foundational layer. What makes ZigBee different at a network architecture level is the 3-role system. Every ZigBee network has exactly one coordinator, the node that manages the network, assigns addresses, and keeps everything anchored to a specific personal area network ID. Then there are routers. These extend the network range and form the mesh paths that traffic flows through. And there are end devices, the sensors, the actuators, that sleep most of the time and connect through a router to reach the coordinator. That 3-role architecture is not complexity for its own sake. It is how you scale a wireless network to hundreds of nodes, behaving as a single coherent system without a central server routing every single packet. The mesh routes itself, and if a router node fails, the traffic finds another path automatically. That is what self-healing means in practice. This module, the XB-S2C, has been validated in real industrial sensor network applications, not hobbyist projects, production environments where reliability is not optional. The rest of this series takes you from configuring your first module all the way to building a live self-healing mesh you can demonstrate on a desk. The engineering behind it, explained the way it deserves to be. So, the decision framework. 3 scenarios, 3 answers. No, it depends. Use Wi-Fi when your devices need internet access, when they are mains powered, and when you have fewer than roughly 30 nodes. Smart home hubs, media devices, anything streaming data to a cloud service, Wi-Fi is the right call. Use Bluetooth, specifically Bluetooth Low Energy, when you are connecting 2 devices or a very small cluster, when data transfer is infrequent and in short bursts, and when you need native smartphone connectivity without a hub in between. Wearables, health monitors, proximity beacons, Bluetooth is correct there. Use ZigBee when you have more than 10 nodes, when battery life needs to last months or years, when the network must survive individual node failures, or when you are operating in an electrically noisy industrial environment where Wi-Fi signal degrades. Distributed sensor networks, factory floor monitoring, large-scale smart building automation. ZigBee is designed for all of it. If this kind of engineering reasoning is useful to you, the why behind the hardware, not just the how, subscribe. That is what this channel is built on. The next video covers what most people ask about first when they get XBee modules. How do you actually configure them? The XCTU software, the coordinator and router roles, why the three-role structure exists at an architectural level, not just which button to click. Make sure you are subscribed so you do not miss it when it drops. One question before you go. Leave it in the comments. Which wireless protocol are you currently using in your project, and what is the biggest limitation you have hit? I read every one.